our last example in our unit is number 14. So it's asking us to equate rational parts and irrational parts. And so what we have to see is that on the other side of the equation, we have a negative 2 plus a y times the square root of 7. That square root of 7 doesn't just come from anywhere. It has to just be the square root of 7. There's no way to reduce it or rewrite it in any way. So anything that we get times the square root of 7 has to make y. Anything left has to make negative 2, and we can use that to our advantage. So we have 4 minus the square root of 7 times 3 plus x times the square root of 7. So, and that's supposed to equal, I'm going to write this in different terms, negative 2 plus y times the square root of 7. So our goal is going to be to rewrite the left side to make it look like the left. So I'm going to FOIL this. So I get 4 times 3 makes 12. The outside is 4 times x times the square root of 7, which makes 4x times the square root of 7. The inside makes negative square root of 7 times 3, which makes negative 3 times the square root of 7. And then the final part is going to be negative square root of 7 times x times the square root of 7, which makes negative 7 times x. Okay, so what we see here is we've got square roots of 7 and we've got other parts that are not. So with this type of problem, we're going to want to group things together. And I would say group it like what we have over here. So I have the square root of 7 stuff at the end and have everything else at the beginning. So I'm going to rewrite this as 12 minus 7x plus 4x times the square root of 7 minus 3 times the square root of 7. Now the goal of this is to separate things. And what we're going to see here is that we have things that have the square root of 7 and things that do not. So our goal is to equate that to this side. So we can do that pretty easily if we factor and we think about how we factor things. So this can stay as 12 minus 7x. On this side, we want to try to factor. I'm going to leave the square root of 7 out to the back end. Now normally I do that to the front, I factor out to the front, but if we look at our example, we're dealing with it factored out to the back side. It's going to make things make sense in a second. So if we take the square root of 7 away from 4x square root of 7, we get 4x. And if we take the square root of 7 away from negative 3 square root of 7, we get minus 3. Now, what this problem is trying to get you to do is link that because there's the square root of 7 over here, its coefficient, which is 4x minus 3, has to make y. Oops. So what we're going to have here is that we know that 4x minus 3 is going to make y. We also know that 12 minus 7x has to make negative 2. So these are two equations. You may think, oh, I'm going to do a matrice. Well, we actually have an equation with two variables, and we have one with one. Always deal with the one that is simplest first. And so if we deal with this, we can actually solve a single equation with one variable. We can get 12 minus 7x that makes negative 2. Then we can get negative 7x equals negative 14. And so x has to be 2. So if x has to be 2, we can go back and look at this equation up here at the top and say, okay, well, 4 times negative 2 minus 3 makes y. So we get negative 8 minus 3 makes y. and we get y to equal negative 11. This is our solution set for our equation, and it's based off of us understanding that the only way to make the square root of 7 is to be part of the square root of 7, and we can't write that in any other way. It's called a surd. It's non-reducible. So anytime we see a square root of 7, we can use that to our advantage to try to group things and then try to make a statement at the end, which allows us to find that x would have to be 2 and y would have to be negative 11.